this talk has got quite a lot of examples and things in it. I might move through them relatively quickly, so if you want to see them as we go along, visit my GitHub page, Purple Blue Flappy Endpoint, and you'll be able to follow that along. Or you can wait to the end and then just have a look at them. Okay, so I'm Billie Thompson, and I'm not really DevOps. I'm a developer who sometimes gets roped into doing DevOps tasks. But I'm going to talk to you today about a few tools and kind of how we use them at the home office, and tell you about a few things that have changed my mind on how enjoyable DevOps actually is. So I work for a company called Transform, and we go into organizations and help them transform their processes to be better. And one of those organizations that we're going into is the home office. So there we've been using a couple of tools. So we've been using Kubernetes, but we've also been using Docker. So in this talk, I'm firstly going to give you, okay, so just out of interest, who here has used Docker before? Cool, almost all of you, excellent. And just for those who haven't, there's going to be a really, really brief 2 or 3 slides on what Docker is, just to bring you up to speed. Then I'm going to move on to talking about Kubernetes and how it solves a few problems that I've certainly found that I have had with Docker. So who here's used Kubernetes then? Who here's used Mesos? Awesome, cool. And then finally I'm going to talk about how the home office uses those two tools together in order to reuse and bring a culture of reuse into our DevOps teams, so we're not having to do everything every time. Okay, so first let's get a list overview with Docker. So what is Docker? So Docker is something which gives you a nice isolated way to run an application, and you get a separate file system, and you get a standardized way to remap ports. So you basically get a way of running applications multiple times on your application, on your host, regardless of how you are, what version libraries you need, because you have an isolated filing system. So this can be a little bit confusing to understand, but if you think of a VM as only sharing the CPU and allowing you to reuse the CPU for different things, the container allows you to reuse the kernel and nothing else. So you have a much more lightweight, isolated process environment. Okay, so Docker's really cool, but it actually has a few flaws. And these flaws sort of start to become apparent when you try and manage Docker on multiple hosts. So firstly, you have all your applications, you have them running inside Docker. How do you actually make sure that say you have 50 nodes inside your cluster, that you're only running your application which only really needs maybe 3 replicas on only 3 nodes? What happens if one of the nodes you've set up one of your 3 instances to run on goes down? How do you handle that situation? How do you monitor for that situation? How do you deal with when you suddenly have loads of load on your cluster and you need to spin up additional nodes? So this is a bit of an issue with Docker, and there's a few different solutions. So the one I'm going to talk to you tonight about is Kubernetes. It's made by Google. It's pretty early days. It's only been at V1 for, I don't know, 2 or 3 months. Okay, so Kubernetes solves a lot of these problems that I've just kind of outlined. Firstly, it gives you a really easy, standardized way to deploy things. So basically you have some YAML files, you tell kubectl to run some YAML files, and it will start up an application inside your cluster, and it will start up the number of times that you specify. It solves sort of a high availability problem in that it allows you to put high availability proxies in front of each of your applications, so you won't ever have to configure HA proxy ever again, which I think is a bit of a blessing. And it also allows you to communicate securely inside the cluster between other containers without having to worry that they're running on the same host. And finally, it solves that really tricky problem of how do you self-heal and how do you manage your cluster by offering you a standardized interface for monitoring container state. So say a container goes down, it will restart it for you, and it will make sure it's running an appropriate number of times inside your cluster. Okay, so just before I launch into talking about what Kubernetes does, I want to cover a few key ideas. So there's 3 main things that you find yourself using in Kubernetes. Those are pods, replication controllers, and services. Okay, so a pod is quite frequently just a single container. However, it can be multiple containers working in unison. The example I always give for this is PHP with PHP FPM and the fast CGI module. So you both need to have the same files running on both of those hosts in order to have that running effectively. So if one goes down, then you probably want to restart the entire application. So it's a single, it's one or many containers which operate as a single scalable unit. So replication controllers allow you to say that you want an application to be running a specific number of times within your cluster. They say they contain within them pods, and you can tell them to, no matter how many nodes are in your cluster, no matter how you scale it up or down, you always have a certain number of applications ready in your cluster. So you could say that you want 2 of your application running, and it will ensure that regardless of the state of your cluster, you always keep 2 of those applications running. And finally, services are kind of like a proxy that sits in front of your pods. It allows your pods to be connectable regardless of where they're running. It essentially gives you a really useful DNS entry that you can query. You'll get an IP that you can connect to, and your connection will be routed to a pod given a specific bit of metadata. Okay, so to kind of bring this back to an example, so what I'm going to do here is show you a really simple application that we use for training purposes at the Home Office. So essentially what it is a PHP application which has 2 endpoints. The first of those endpoints always returns 200, and the second of those endpoints returns like random states. So it might return a 404, it might return a 200, or it might return, it might just return a 200 but take a really long time. So sitting in front of those, we're going to have a service, which is, okay, so the application part is going to sit in the back replication controller, and we're going to run it 2 times. Sitting in front of that, we're going to have a service. This service is going to allow those applications to be connectable. And then sitting in front of that, we've got some Nginx pods, which are going to terminate our SSL, because I like to be a good internet citizen and make sure that our customers can have end-to-end encryption when they're connecting to my website, even if it's a rubbishy example. These are going to sit inside a replication control that's going to make sure there's at least 2 of them running. And finally, sitting in front of them, we're going to use a service, which is a load balancer, and is going to provision an external IP for itself and allow us to connect in from the outside world. Okay, so this is the sort of YAML that you get when you set up an application controller. So I know this is kind of massive and probably a bit small. So if I just zoom in on the individual part here. So what we are doing here is we are defining many of the things that you'll see if you start a pod using Docker. So we have a name of the image that we're going to run. We have a number of ports that we want to expose from our application. So in this case, port 80. I'm giving it the useful name HTTP. And then at the top there, you can see there's a liveness probe. So what this means is if my PHP application stops working, then the container will be killed, thrown away, and restarted. And hopefully that will self-heal the application. Okay, so this pod sits within a replication controller. So there is lots and lots of metadata here. So this is the non-red bit of that last diagram, by the way. So there's lots of metadata in here. So there's some labels. And what these are is a handy way to refer to the containers inside Kubernetes. Most importantly, though, we have a replica count of 2. And what this means is inside Kubernetes, when we launch this application, we are going to make sure there's always 2 of the application running inside the cluster. Right, so I'm not going to talk you through the replication controllers for the Nginx containers, because basically they're exactly the same as that, and that would be pretty boring. So I'm going to just skip you to the load balancer. Now, the load balancer that sits in front of the Nginx proxies looks like this. It's exactly the same as the load balancer that sits in front of the PHP application containers. So there's a few things that you probably want to notice here. So we have some ports. Now this says expose something via port 80, and it's got a target port in there as well. So we've got a target port of HTTP, and what this refers to is a named port which is on the container. So we're saying that any connection which comes into port 80 on this will try and connect to whichever port is named HTTP on a container. And because this is going to connect to the SSL endpoints, we actually have a 443 endpoint, F443 port there. So this is exactly the same as the PHP service in many respects, but there is one big difference. So there is a type down at the bottom there, which is load balancer, and this will tell Kubernetes to go away and provision a load balancer inside whichever cloud you're using, AWS or Google Compute Engine, and it will create an external IP which you can then use to connect into the system, and it will be routed through to your pods wherever they are running. Okay, so that's the load balancer. So I realize I've been a bit vague and only really talked about concepts here. So this is actually what I'm talking about getting up and running and deployed. So it's a really simple endpoint. It's got HTTPS, I don't know if you can see the little green logo, 2 endpoints, one which returns random responses and one which always returns A200. Sorry, it's a bit small, we'll see it a bit bigger in a minute. Okay, so there comes a point when you've kind of got sick of learning things about random bits of the cluster. And you want to actually deploy it onto something, and you want to see something doing deploys. Okay, so this is how you do deploys with Kubernetes. So I'm just going to show you what's in my personal cluster for Kubernetes, and I'm just going to prove that there's nothing up my sleeve because I haven't got any sleeves. And there is no endpoints there which are labeled Flappy. So after I recorded this, I learned that about namespaces which allow you to limit it to a single application. But we'll gloss over that. Okay, so all you have to do to launch things into your cluster is to do kubectl create -f and then provide a path to some YAML files. And then if we look here, we can see there are 4 new pods at the bottom which are ready 0, and they've just flicked over to ready 1 now. And you can see there's 2 services at the top now which are new, which are Flappy Nginx and Flappy Silex. And there is a bit of a gap there where we're waiting for Google Compute Engine to provision us an external IP. So once we've done this, we should be able to connect to that external IP and connect into our application. Give it a couple of seconds. Please? Yeah, there we go. Cool, okay, so I can hit that and then, yeah, it's working. Awesome. It's almost like I filmed it beforehand. Cool, yeah. So that is how, that's the endpoint and it's up and running. So I guess there is a next step though. Once you have deployed your things onto the cluster once, obviously this doesn't happen to me because I write the perfect code first time round, but other developers I've heard maybe have bugs sometimes in their code, and you need to do releases and include new features. So this is how you, a really basic way to do updates in your Kubernetes cluster. Okay, so this is a 404ing endpoint in Silex. It's /v2. So what I'm going to do is I'm going to add in an additional endpoint. So it's going to be the v2 endpoint. This is PHP, by the way. You all love PHP, right? Okay, so and because I'm a good citizen, I'm going to, once I finish doing that, I'm going to edit the comments because I like keeping comments up to date. So what I'm going to do here is I'm going to commit this, and then I'm going to push it to a service called Key, which is an online Docker repository, somewhere where you can share Docker containers. And I'm going to use the CI service, which is built into Key, which will, on a Git push, rebuild the container, but if it matches, if it's been tagged with a specific semver style version tag. Okay. So you might notice a little bit of subterfuge here, where I've just done the build. Oh, and then suddenly it's done, finished. This is because on Key, builds take about 10 minutes, and I didn't want to subject you to 10 minutes of watching this build. So it's a bit of a trade-off. It's a free service, but it's not often not the fastest. Okay, so what I'm going to do now is I'm going to do a rolling update of this new image with the v2 endpoint, which I've just built. So you can see here that what I'm doing now is looking up the name of the replication controller that I want to deploy this new version of the image into. So I have name of the replication controller is Flappy Silex V1. It's just 3.4 from the top there, and the image is at the bottom. So I'm issuing kube control, rolling update, image, Flappy Endpoint, Flappy Silex, version 1. If you have multiple containers in a pod, you will need to do something, which is you have to specify which particular pod container inside the pod you're addressing, but it defaults to whatever's the only one in there if there's just one. Okay, so I've issued the rolling deploy. So what this is going to do is, firstly, I'll put this down for a minute. So firstly, we've got two pods running in this. So we have two old pods, and then what we're going to do is we're going to start up a third new pod. So we've got 3 running. Then we're going to wait for 60 seconds, and we're going to kill off one of the old pods. So we've got one new one and one old one. So we'll be in a state where we've got 2 different versions running in the container at the same time. Finally, we'll kill off the second of the old ones, and we'll have 3 running at once. 2 running of the new ones. Sorry, I made that sound really confusing. Basically, it goes like this: old, 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 new, 60 seconds, new, old, new, old, and then trust me, go easy, clear, right?
How many Docker hosts are there?
So in my cluster there are 5. Okay, so we've actually just ticked over the from having 2. So we're now in the state where we've got 1 old one and 2 new ones. So if I flick over to the browser now and we have a look at the service, you'll actually be able to see that we're in a state where we've got 2 different versions running at once. And sometimes I'll get a 404 for the page, and other times I'll get the actual new code which is in there. So I know this isn't always desirable, but there is actually a fully featured API which makes it really easy to do more complicated styles of rolling updates. Okay. So if I just request this page, there we go. So half the time it's working, half the time we've got an old version. If you want to do this through an API, then you can do more complicated things like red-black deployments and replacing services, so you don't have this downtime where you're running 2 different clusters. It does require extra work. Rolling update is built in, so I tend to use that because I'm lazy. Okay. Cool. So we've reached the state where it's now running 2 of the new containers and none of the old ones. So we have released a new version to the cluster, and it's working great. Okay. So I really think that Kubernetes kind of solves a big piece of the management puzzle for managing Docker. You don't have to deal with any of the horrible Ansible, Chef, Puppet things. I don't like dealing with that because I know they're supposed to run multiple times, but they only ever really work for one host, and that's the first one you write them for. It comes with loads of really useful stuff out of the box. So the first one is obviously rolling updates. So I'm a developer. I want to get my code up and running, and I want to update it. And those are the 2 key things for me. However, it does get a load of other things that I always consider more mature DevOps environments having. Firstly, health checks, so that you can tell your application's running. So right at the start, I showed you I had a liveness check inside my replication controller. So if my pod goes down, then I can have it killed and restarted. And there's obviously a RESTful API for that. So if you really want to, you can tie it into Nginx or PagerDuty or whatever you prefer using. Finally, services offer you a really nice way to do high availability and connect to your pods wherever they're running, your containers wherever they're running. And finally, resource limits. I haven't really touched on this, but this is a feature of cgroups which comes free with Docker, and you can basically say things like, I only want this particular container to use, 100 megs, or if it's a Java application, maybe like 5 gigs. Or you can do limits on the amount of CPU that you can use as well. Okay, so I really like these 2 tools, and I think they're fantastic. And I got to be honest, I obviously like them so much that I started paying for a Google Compute Engine so I can host my own personal projects there. But I'm going to talk to you now a little bit more about how we use these tools at the home office and how we've used it to create a culture of reuse within the DevOps teams. Okay, so firstly I'm going to talk about how and what things we reuse. Then I'm going to talk about how we think like a platform in order to reuse things on a more wider scale. And finally, I'm going to, because lots of you probably have data in the home office, probably, I'm going to talk about security so that you feel a little bit more comfortable that we've got your data. Okay, so I think there's a few different things that is pretty well known that you can reuse. So you can always create libraries for code and reuse code that way, pull it in with whatever dependency management tool is in vogue for that particular language. So I don't know, NPM, Composer, Gradle, Maven, all that sort of stuff. So that's a pretty well understood thing. So we obviously reuse libraries at the home office and make pains to make bits of code reusable. But also we reuse Docker containers. So we develop applications in Docker and we share them among people inside the home office and also outside the home office. And we make sure that we can actually take advantage of these running in multiple different environments without having to repeat the work. And finally, we reuse environments. We don't try and have a dedicated environment for every single thing. We make sure that we're creating services that people can reuse as a sort of DevOps team, rather than focusing on doing bespoke DevOps work for every single project. So we end up reusing environments where it's appropriate. Okay, so it's not always easy, though, introducing a culture of reuse into an organization. So in order to do this, we looked at the most successful a reuse project in the world, which is the open source project. I mean, even the most staunchly closed source applications reuse things from the open source world. Like, have a look at Adobe, who, if you have a look in their licenses thing, they've got loads and loads of open source things that they've just used in their product. And there's even, like, Microsoft used the, BSD kernel for their networking for ages. So we wanted to get some of that reuse into our thing. So the first thing that we did was we made our permission structure for our GitHub private account really, really flat. So anyone, you just have to be a trusted developer of the home office, and then you can see any projects and determine whether they are fit for you to reuse. But I mean, this wasn't enough. We found that actually people didn't quite, make their projects, put your projects in a state where you could actually reuse them. Quite frequently, they were missing readmes, and you had no idea of how to actually use these applications. They were just kind of code which was up there that you could look at. So we had a look at other things that could motivate people to actually keep these up to date. And the thing that we found was that when you start open sourcing things, people care a lot more about them. So people start, when their name is associated with them in the public domain, they start doing things like developing really good readmes. Generally, they start being good people. So they start doing all these things which are in this list. So they version stuff using Semver, which is obviously fantastically useful because you can tell when they're like going to break stuff, which is a problem that you have internally, but as well as externally. So it's something that you maybe don't know is a problem in your organization until you start introducing Semver and you're like, oh, actually, yeah, that was a massive issue. Finally, you write beautiful documentation because you want people to know how to use your application. You want your friends, you want to go to DevOps meetups and get people to reuse your containers and code that you've produced because you think it's cool. So in order to do that, you need to write documentation. You need to license stuff as well, so you need to include how to use how your applications can legally be used. And finally, you do other nice things like include codes of conduct and those things which help set culture inside an organization. Okay, so on top of this, we also think like a platform. So we provision services commonly which people can use. So Jira, Git, and like file hosting, we have our own internal S3 because we're kind of we have some unusual encryption requirements maybe for our documents. So, but this isn't where we stop thinking like a platform. We start operating like a PaaS. So we are, as a DevOps team, focused on developing a Kubernetes PaaS for the rest of the team, the rest of the home office to use. So we can get developers up and running using a standard interface. The really cool thing about this is although we prefer CoreOS on AWS, and we run Kubernetes on top of that, we can actually deploy this on vCloud or some other internal system. All we have to do is make sure the developers have a working Kubernetes installation, and anything that they've written before will work just as well. Okay, so finally, this is kind of the last bit in my slide, so last bit in my presentation. So they've got a few tips for ensuring that you maintain security. So the first one is, although Docker and Kubernetes give you wonderful isolation of your containers, you can still get exploited by data coming in. So use web application firewalls. We've got an open source one that is sort of pre-configured, OpenResty. So I've got a link to my GitHub on the next slide on the Home Office GitHub, so you can go there and use that if you want without having to set one up yourself, which might save you some time. Another key component of keeping your platform secure with Docker is you have to control your upstream containers. And it's really important that you don't keep using random open source Docker containers, because you might end up using 5 or 6 different operating systems, which means that you're going to have to look out for exploits on 5 or 6 different systems, as opposed to just having a single one to manage. And finally, although all this reuse of platforms and environments is really cool, sometimes you just make too juicy a target by putting all the data in one place. So you have to separate it out and create physical separation between environments. We have wonderful people in the Home Office who work in security who can tell us like when we need to do this. But if you use these tools, when you find that you need to do this, actually this becomes really easy, because you can reuse your Kubernetes files, you can reuse your Docker containers, and it's exactly the same as your AWS shared environment. Okay, so it's still pretty early days. It makes management of your Docker containers really, really easy. Hosting agnostic. And you can play with it today. So I would recommend that you go visit that link and have a play with Kubernetes in Vagrant. There's a link to all the code which I've talked about in this example, in this presentation. I know I might be a bit light on how they connect together. So there's a full example there. You can see all of it. And finally, just to prove that we practice what we preach, and if you want to use that WAF container, we have the UK Home Office github.io, so you can see all of the stuff that we do there and see all our lovely open source containers. Yeah. Has anyone got any questions? Okay, so how do we secure our own hosting inside the Home Office? So we do a number of different things. So one of the key things is that actually quite frequently we'll use air-gapped systems for really high value bits of data. So although we might be using a virtualized environment on a private virtual cluster, it will be hosted inside the UK in a private Home Office data center. And we will manage that using something like vCloud and create Kubernetes on there. But actually we will reuse the containers and things that we have and put them on there rather than, and maintain a sort of air gap between that and the internet. So that's sort of, I guess, how we do our sort of more high value stuff. Or from a more low value sort of perspective, we take the same approach as like industry does. So we host on the public cloud and we make sure that we do things like encrypt our data. We don't put too much of one data in any one place. All the standard things that you would do working for a private company for our slightly lower value sort of systems. So the question was, how did we get developers on board with moving to Docker and changing working practices? I guess it's kind of an ongoing process. I think the first thing to do is to do things like this, do lots of talks, talk excitedly about things. We have kind of like a group where we meet together of all the sort of senior developers and senior like team leads, and we get each other excited about these new technologies and new techniques that we're using, and then we communicate to the team with the same level of enthusiasm that like we obviously have for these techniques. But yeah, it's tricky. There's no like one solution for one team. It might be something very different. It might be someone going, you need to do this. But for another team, it might just be someone going up and going, oh, this is really cool. Like, you should try it, and then people do it. It kind of depends. It's tricky. Sorry, I don't know if I really answered that.
One more question, Billy. Pick a hand.
So you're at the back. I saw you shoot up at the start. Okay, yes. So to stop things from breaking out of the Docker container, we run unprivileged containers 90% of the time. And for things like where we need to do builds like Docker and Docker, we actually have a separate Docker server, and we have that for building, doing Docker and Docker builds. So actually what a user gets is like the ability to run containers rather than like the ability to do anything at all in Docker. Yeah, so we're looking at moving towards using SE Linux. I don't know too much about that, unfortunately. I do mostly come from the kind of like a developer using this kind of side. But I know that SE Linux is one of the things that have been mentioned. I think the mostly what we're doing at the moment is running unprivileged containers.
Thank you, Billy.